Okay, we are live. Yep, beautiful. Friday homework 5, 6, and what were we at? 9-2. Yeah, good. Okay on the assignment. A lot of us, I hope, finished it before now. Hopefully, you got up this morning because there weren't very many that had it done by 6 o'clock this morning. We're going to do 9-3 today and the errors. I got to butt that up together because the snow days hurt us pretty bad, right? We'll review Wednesday, Friday's B, test Monday. Okay. So you guys kind of, I don't want to say, I don't know if it's advantage or disadvantage because B day's got test Friday. So you guys get the extra 2 days. So that's where we're at. So we'll teach today. 9-3 is not bad at all, but I want to make sure you guys got 9-2 down because depending on if 9-2 is bad, then 9-3 is bad. If 9-2 is not bad, then 9-3 is not bad. That's kind of how it rolls. Let's see, how did you knuckleheads did on your homework? Anything y'all need help with on those assignments, those questions, something I need to clear it up. Y'all are acting so different today. What this first hour, 9-1. Let's see how we did. Good gracious. Responses. Get here. All. I don't want to single out anybody. More lefties. That's the same question from 9-1. It's on 9-3 too, knuckleheads. It's the same one. We're not learning. It's because you can't guess. You have to put a number in there. I know how this rolls. Use simulation to estimate the p-value. P hat is 0.16. 0.16 is right here. So count those dots, count those dots, count those dots, and count those dots. Because the p-value is the probability of getting the sample observed or greater or more extreme. In this particular one, it's greater because ha is greater than. So you count all those dots and take it out of 200 dots because it's out of, I think it's out of 200. There it is, 200. Yeah, there's 200 dots. So count those dots out of 200, and that's the probability of getting my sample or greater. This is like a good question. You guys really need to understand that because that's kind of like the big deal of understanding what the p-value is. And then you got the second part. Maybe you're missing it because you don't see the second part. I don't know. Assuming the true proportion is, so fill those in, okay? All right, don't be missing that again. That's on the same homework again. Teen drivers, what's this one? We got ho, p equals 0.6. That's the null hypothesis. Oh, okay, just check it. Oh, well, sometimes I get in trouble for talking about hoes in class. Sometimes. P equals 0.6. Ha! This is that tricky one that I told you guys might get you at some point in time. This is a ho equals, this is ho not equals to, right? It's a two-sided test, two-tailed test, okay? Where P is the true proportion of teens who pass their driving test on the first attempt. So they think it, or the claim is 60% of teen drivers pass their driving test on the first test, and then they don't. It's not 60%. We don't know if it's higher, we don't know if it's lower, we just say it's not 60%. We got a confidence interval for 95 that said it was 0.607 to 0.769. That bad boy's not in there. This is not in my confidence interval. If that's not in my confidence interval, this is really not a plausible value. Therefore, you have to reject this null and say there is enough or is significant evidence to say that it is not 60%. We don't know if it's higher. We don't know if it's lower. We just know it's not 60%. And what was it? A 95% confidence interval. Therefore, alpha has to be 0.05. All the statements are true. The value of 0.6 is not plausible value because it falls outside of it. Based on the confidence interval, we would reject P is equal to 0.6 at the 0.05. That is true. The 95% confidence interval provided gives us an approximate set of hose that would not be rejected. I think that's true. A two-sided test only allows us to reject. Test only allows us to reject or fail to reject a hypothesized value for a particular. Oh, which of the following is not true? Oh, they're all true. That explains it. I think they're all true. So that again, don't necessarily know which one's right, know which ones are wrong and why. One more. Uno más. Bullies in middle school. A media report claims that more than 75% of middle school students engage in bullying behavior. A University of Illinois studies on their aggressive behavior surveyed a random sample of 558 middle school students. When asked to describe their behavior, the last 445 admitted they engaged in physical aggression. That's a whole lot. Holy cow. Social ridicule, teasing, name-calling issues. Do these data provide convincing evidence at the 0.05 significance level? So I put this one on tonight's homework too. So you guys should be comfortable finding the z-score and turning it into the p-value and deciding on if you're going to reject or fail to reject. What else? Man, we got to do better on our homeworks. I'll leave it at that. I know, we got busy days. You got tests next Monday. Let's get it together. Where are we at? 9.3. AP Stats. AP Stats. 9. Let me wait for this thing to bounce. Patience. Patience. Y'all are being so quiet today. They're being so good today, Dr. Walson. You have to come by more often. Man. I'm kidding. They're always like this. 9.3. 9.3. 9.3. I won't pick on anybody. You can raise your hand. Give me one condition needed to perform a one sample hypothesis test. No. Got to have a random sample. Somebody else give me another one. Hit me, Z. Large counts. And how do you prove large counts? That's a tricky question. Okay, and then somebody tell me where students mess up on hypothesis tests compared to confidence intervals. Sully, you know? They do p-hat instead of p. Always use p if you don't know it. Man, you guys are sounding like you're really like, I know what I'm doing. Good. There's one more condition. One more, hit me. And what does the 10% mean? The sample needs to be less than 10% of the population. Or you could say the population needs to be 10 times the sample. You could say it that way. That's moving it to the other side of the equation. That's like doing math. Everybody okay? Now that one doesn't get checked if what? If it's an experiment, right? Don't check that one if it's an experiment. Most of the time, guys, one sample, they're not experiments. When they're two samples is when they're experiments. You typically force one group to do one thing and force one group to do another thing. And so sometimes two samples are more likely to be an experiment than a one sample. Okay? So those are the conditions that are met. Guess what? They're going to be the same conditions today. Same ones. And the same ones next week, and they're going to be the same ones next week, and they were the same ones last week, and they're going to be the same ones. How you prove large counts changes a little bit. How you prove large count changes a little bit. But other than that, they're the same. They're the same. Everybody good? No, I better not. We're good. Click. So, testing claims about proportions, same thing, 9.3. Now we're going to talk about the difference in proportions. Okay, the difference in proportions. I got that. Red line. Click. A lot of times, guys, we're not interested in what the claim is. 60% of the students or 60% of teens pass the test on the first test, driving test. We're not interested in that number. We're interested in maybe a group or one population being bigger, smaller, higher, lower, different than another population. So if I wanted to go to like the driving test, maybe we think that females have a better chance of passing it on the first time than males, or vice versa. I don't know if that would, but I'm again just going back to that driving test. Okay, I'm not necessarily care that it's 60%. I'm saying if one of them's higher than the other one, or lower than the other one, or if we just think it's different. When this happens, we're dealing with two independent random samples or two independent populations. Okay, so here we go. First thing I want to talk about before I talk about the conditions is I want to talk about the hoes and the haws, or the hypotheses, okay, because they're different for this. Guys, we in 9.2, we always set a value right here. We always set a value right here and what we thought it was, or what the claim was, or whatever it might be. Now what we got is, because we have two different groups, we're not putting a value here. We're going to say that one of the groups is the same as the other group. And so that's always the hoe. That's always the hoe. We have to assume there's no difference. We have to assume that they are the same. So we're going to assume there's no difference between the two populations. It's still populations. Don't put samples here. It's still populations, not samples. That the two populations are the same. We think that they're equal, however you guys want to talk about it, okay? But that's always going to be our hoe when we're talking about two, wow, that was a shower, two samples. Well, I didn't go all the way out there. Okay with that? Good? And then the ha is, we think one of them's less, or we think one of them's greater, we think that they're different. So they will write it like that, AP will. AP, instead of writing it P1 equals P2, they're going to move that bad boy over there, and they're going to say P1 minus P2 is equal to 0. That's the way AP will write it. I always write it like this because it just makes a little bit more sense this way. But most time AP will write it like this. Just understand that that's just a quick mathematical. If I move that over there, then I got this equation. If I move the P2 back over here, then I got this equation. So it's just a different way of rewriting that equation. Everybody okay with that? Any question? Good, 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 good. That's always going to be the hoe. That's always going to be the hoe. Always going to be the hoe. So P1 will equal P2, or P sub B will equal P sub G, or P sub 12 will equal P sub 11. I'm at 12th graders and 11th graders, or whatever group. You don't have to use 1s and 2s, right? We can use whatever we want, whatever makes it easier for you guys to talk about. Okay? No pencils, no pencils, no pencils. And then the alternative is, we think one of them is less than, or we think one of them is greater than, or we think it's different. And again, AP will write it differently. AP will move this over and they will say P1 minus P2 is less than 0. They'll say P1 minus P2 is greater than 0. Or they'll say P1 minus P2 is not equal to 0. They'll do one of those three for the alternative. One of those three for the alternative. I like the top way. The top way is really evident to me that I think P1 is less than P2. I mean, that's just, this one, it takes me a little bit to realize that if this is negative, that must mean that P2 is bigger than P1. It's just a little bit more confusing to me. So, but just understand that. You guys are smarter than I am on that. You guys can probably see that a whole lot easier than I can. Y'all okay with the alternative and then nulls? Any questions? I don't see a whole lot of pencils going. Must be pretty easy. It's pretty easy. It isn't too bad. The ho's always that, and the ha's one of those three. One of those three. Remember, the equal sign has to go with ho. Always use parameters. We don't use samples, those little bitty things like that. Okay? And then this is where I talk about the other way to write those three. So, anybody still need some time to put that down, or we got it? Good, 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 good. Clicky, click, click. Breakfast time. No. She's supposed to be an attention getter.
Can we do it again?
Everybody good? No more questions? Everybody, no pencil? Okay, here we go. Breakfast time.
One more time.
No. Y'all got to wait for Ross Geller again to go, woo-hoo! Thank you.
Will we have another opportunity?
Nope. You get one. One chance. Well, it's all right. It's what I did during my snow days to try to find some freaking little fun stuff. Obviously, it worked really well. It's engaging. The second time. Yeah, well, too focused on your computer and not the lesson.
Yes, sir.
Oh, it's a good thing I'm tea dropping. Research has designed a study to compare the proportion. Told you guys, proportions. They're not going to trick you with proportions or means. Okay? Proportion of children who come to school without eating breakfast in 2 low-income elementary schools. We have an SRS of 80 students from school 1, and it found that 19 missed breakfast. We have at school 2, we have an SRS of 150. Why they took a whole lot more, I don't know, but they did. And they had 26 who missed breakfast that day. More than 1,500 students of school attend that school. Therefore, I'm guessing we're trying to prove the 10%. Do these data give convincing evidence of a difference in the population proportions at the 0.05 level? State the appropriate hypotheses for performing a significance test. So we don't have to do this test yet. We're just going to state the hypotheses. So ho. Remember now, don't put ho equals. That's a uh-oh that some students like to put. We know that P1 has to equal P2. And they actually have done nice here because they said school 1 and school 2. So that's what I'm going to do. I'm going to do school 1 and school 2. And then I got a ha. And this has to be P1 and this has to be P2. And what do we do to the convincing evidence of a difference? So they don't think one's higher. They don't think one's lower. We just think it's different. And if you only do this amount of it, then you're only going to get half the points. Because you have to do what? One more thing? Anybody else know what we got to do next? Wild guess? Not conditions. No, that's to do the test. What else do I have to have for these things right here? Hit me? Define them. Tell me what these are in words. Anytime you have variables, guys, somewhere in there, you got to tell me what they are. And so we have to tell me P1 is the true proportion of students who did not eat breakfast at school 1. Is the true proportion of students not eating breakfast at school 1. Yada, yada, yada. Please make sure it doesn't say, don't say is the proportion of students who answered, because that tends to make me believe I'm talking about the sample. We're not talking about the sample, we're talking about the population. Now guys, AP will, I will, it's okay to do a bunch, because this is going to be the exact same thing. The true proportion of students at school 2. So because it's the exact same thing, you can just write it down. Or what I'll get some students do is I'll do P1 and P2, and then I'll go, whoops, sorry, and we'll write this, true proportion of students at school 1 and school 2, and then come back together, who did not eat breakfast. Y'all with me? You don't have to write it down in words both times because it's the exact same thing underneath it. Yes, ma'am. True proportion of students who did not eat breakfast. Yes. I know. I got lazy. You get this hieroglyphics up here. That's a do as I say, not as I do type thing, right? Any questions about what you need to put here? Like I said, the context, you guys have been doing pretty well at it. You guys, the only thing that might mess you up is you just tend to make me believe that that's the sample. And that's why we want to put true proportion of all students. If you really want to be sure, right? We want to make sure you're talking about everybody, not samples, not samples. Those are little bitty things that get us getting from A's or keep us from getting 5s. Like I said, they don't keep us from failing, but just enough to keep me from getting A's. And we don't want that. We want the A's. We want the 5s, 4s, 3s. No pencils. All right, good enough? Here's non-hieroglyphics. They put P1 minus P2 equals 0. I told you, of course, that's easily acceptable also. That's more letters, more lead, more ink. The true proportion of students at school 1 who missed breakfast today. I don't know if I talk about today. Who did not eat breakfast, I think is where I would leave it. Good enough? That today kind of just means that, Conditions, we already talked about these. We already talked about them, right? Except what now? Instead of what, an SRS, that was no, we had an SRS, now we what? Have 2 independent random samples. Okay? 2 independent random samples. We have an independent random sample from school 1 of, I forgot how many kids that was, 86? 80. Independent random sample of 80 students and an independent random sample of 200 students. I forgot what it was, 150, sorry. So 2 independent random samples. Okay. 10% next. Yeah. Both samples need to be less than 10% of the population, provided it's not an experiment. This was not an experiment. It was a random survey, a random sample. Okay, random sample. And then we got to lock in on the third one because it's changed just a little bit. I mean, still need large counts. How you prove large counts is different, which you guys understood that already, but it's different than what we've done in anything. Okay. So approximately normal or large counts. I told you guys that our book does large counts. But notice that how you prove it. We've always done n times p and n times 1 minus p. Now we have to do n times, and they're going to call it p sub c. So we don't have p hat. Don't use p hat. Don't use p for this one. We're going to use p sub c. No, it's a little confusing. And like I said, how you prove large counts is different for every single test. And that's what makes it difficult, guys, because now we're up to our 4th test. We're up to our 4th method, and every one of them I've had different methods for proving it. 8.2 was n times p hat and n times 1 minus p hat. 8.3 was n p hat 1, n p hat 2, n 2, right? We had 4 of those. Now we did n times p, n times 1 minus p. And now we're going to go n times p sub c, n 1 minus p sub c. Then we got to do n2. So we have to do n1 and n2. Okay? Let me tell you what p sub c is. P sub c, oh my gosh, here we go. It's just basically adding both combined. the successes over N1 and N2. You're going to combine the data. That's why it's P sub C. It's combining the data together. And why they do that, there's somebody a whole lot smarter than me and a whole lot smarter than you, because I know you guys are better than me, came up with this. And so that's what we have to do. We have to combine the data together. Okay? Now, our calculator does it for us, and I'll show you that. It's on our formula sheet. It's kind of, there's a little bitty trick out there on our formula sheet. And so I want to make sure I show you that, so hopefully you have the aha or oh yeah moment when you're taking the test next Monday. Okay? Make sure I didn't. A significant test begins assuming by P1 is equal to P2. To estimate P to C, we're going to pool the data together. That's what they call it. For some reason, they call it pooling it together. All right, here we go. Same lunch data. Same lunch data. Check if the conditions are met. 2 independent random selection. And then I'm going to go off and I'm going to do a little bit more. And I'm going to say 80 students, school 1, 150 students, school 2. Don't just say you checked it, prove you checked it. Don't write a novel, but don't SRS check, right? 80, 150, less than 10% of all students at school 1, at school 2, at each school. That's probably, how about we just do that? At each school. That'll work. That'll work. That's why they said there's at least 1,500, right? Because this is close. But it said there's at least 1,500. So that verifies that part of it. Now we have to combine that data together to get me that P hat sub P sub C, P hat sub C. It's actually it's P hat sub C is what it is, because it's coming from the sample. It's really P hat sub C. And so I'm going to take these 26 and whoops, I think I did it backwards. 19, I did, it's okay. Mathematics doesn't matter. And 26 out of the 150 and the 80. You don't have to show that. It's nice that you do, but you don't have to. But you do have to tell me what P hat sub C is. You have to state that somewhere. Okay, and that's why you guys have this wonderful calculators that do that for you. And again, I'll show you on your calculators where it gives it to you. It gives it to you. It gives you that P hat sub C. One of the few things this calculator will do. And so I got to figure out what that is. I'm going to cheat. It is 0.196. 0.196. And so now we have to go to the 80 times the 0.196 and the 80 times the point, what's left over, 804. And the 150 times the 0.196 and the 150 times the 0.804. And use your little calculators and tell me what those numbers are and just say they're all greater than 10. Whoa. Let me do non-hieroglyphics so you guys in the back can see. This comes to 15.68. This comes to 64.32, 15.68, 64. That's not right. There's no way it came up to the same numbers. You got it? Are any of them right? No pressure. Or is it A?
That one's 29.4.
29.4. 120.
120.6.
Like I said, guys, you don't have to show this, but you have to show this. Somewhere you got to tell me what P hat sub C is. I do that in my calculations. It's just one of the things I tell you because my calculator gives it to me, so I just do it in my calculations. Y'all okay on the conditions? How many points on the test? You don't know? 3, 4, somewhere in there? It's worth that on the AP exam. That's its own EP or I. That's its own EP or I just by checking it. It's going to drop you to a P if we don't do P hat sub C. Yay? Good enough? Easy peasy, lemon squeezy. Same formula, standardized test statistic parameter, standard deviation of the statistic. That's what's on your formula sheet. That's what I told you guys. It's your job to turn that into letters. And so this time we're still going to be Z. Your statistic now is not going to be P hat. It's going to be P hat 1 minus P hat 2. Okay? Your parameter is going to be P1 minus P2. And then the standard deviation of the statistic, I don't have it memorized. So I have to give it to you. But it's on your formula sheet. It's different than all the others. It's different. I just want to get you guys this part first. How many times are you going to write the formula? Probably not many. Why do I need to know that? Because you're going to see it on the multiple choices. Now, here's a little thing again, guys. Man, what did we say the whole was? P1 equals P2, right? Or we said P1 minus P2 is equal to 0. So you won't see that part because P1 minus P2 is 0. And that confuses students a lot when they first see this. Because you see P hat 1 minus P hat 2, and it looks like it's P hat 1 minus P hat 2. I'll say that again, just so you're going to see that. You're not going to see this because that's 0. And that's this part of it. That's 0. You're going to see P hat 1 minus P hat 2, and it's going to make you think that that's P hat 1 and that's P hat 2, and it's not. So that gets a little confusing. Just kind of soak that in, okay? And then let me give you the standard deviation of the statistic. So, oh, there that is, there that is. There it is. It's P hat sub C, 1 minus P hat sub C. 1 over N1 and 1 over N2. Okay. Get that down and we got to go to formula sheet. Pencils, they're still going. Doing very good at allowing time to process for the students, Dr. Walson. I'm just let you. I know. Well, see, that's what I'm trying. That's the goal, is to keep you focused, so that if no one shows up, it just sorry. All right, formula sheet, guys. Formula sheet, formula sheet, formula sheet. Same one you guys have showed all year. Okay, same one you showed all year. Let me make it bigger so you can read it. Oh, I didn't want to go that fast. Come here. Whoa, what are you doing? Okay, here it is, standardized test statistic, parameter, standard error of the statistic, okay? You're gonna go to this page here. Now's when you really got, this is, like I said, this is when you start using your formula sheet if you haven't already. Here's 8.1. That was, I'm sorry, 8.2. 8.2, 8.3. 9.1. 9.1 or 9.2. 9.2. We don't use, that was sampling, that was chapter 7. When P1 equals P2, when P1 equals P2 is assumed, which is our whole. And we have to assume whole is true. So we have to go off of this. This is the only time we'll ever do this. And here's where they'll tell me that P hat sub C, 1 minus P hat sub C, N1, N2. And here's where they actually tell you what P hat sub C is. X1 plus X2, N1 plus N2. So this is the only time we're going to use this is 9.3. When you have two sample proportions, it's got proportions. Okay? So when P1 equals P2 only happens when we have a whole when P1 equals P2. So we're going to follow this part right here as my standard deviation of the sampling distribution. And if you forget what P hat sub C is, there's P hat sub C. Probably going to use it. Probably will now for all of these because we got so many of these things going on. You want to make sure you use the right one. But remember what I told you about the formula, right? You don't have to write formulas unless you just feel really good about it. However, multiple choice, you're going to see your answer in formula-wise. They're not going to give you the answer. They're just going to put them in formula-wise. Very, very, very common for multiple choice to try to change this up a bunch of different ways. They'll try to make it look like this. They'll try to make it look like this. I don't know what else they'll try to do. But that's an A, B, and a C right there. So just recognize those things. Everybody good? Okay? I don't think there's anything else different on this stuff. Explain why the sample gives me some evidence. Well, I got P hat sub 1 is not equal to P hat sub 2. P hat sub 1 is 19 out of 80. P hat sub 2 is 26 out of 150. And those are not equal. So that gives me some evidence. That gives me some evidence. They did it a little bit different, right? They're showing that the difference is 0.06, which is not 0. They don't care how you prove this. I would have just gone to saying 19 over 80 does not equal 26 over 150. That gives me some evidence. That's all I need. This is P hat sub 1 does not equal P hat sub 2. That gives me some evidence that my ha is true. Some evidence that my ha is true. Now they want me to calculate the z-score. So let's go ahead and calculate the z-score. Z is equal to P hat sub 1 minus P hat sub 2. I always put the minus the 0. That way I don't get confused about that being the parameter. And then I got this square root of this nasty, crazy thing right here. But again, guys, I'm going to let my calculator do the work. Let my calculator do the work. Uh-oh. Dang it. Calculator. Look, let me make it bigger. Clear. Clear. Stat tests. Don't do 2 samp z tests. Go down to your props. 2 prop z test. X1. Was it 39 cats? I don't remember. 39 out of 80 didn't eat breakfast? 19. Okay. 19 out of 80. And then my second group was 26 out of 150. Okay, here's my alternative, not equal to, less than, greater than, and I'm just calculate and draw or whatever, calculate. Notice here's gives me the z-score. There's my p-value. There's p hat sub 1. Here's p hat sub 2. And then that one tells me p hat, which is the p hat sub c. Just these TIs they're great. We love them. So glad we have them. Yep, I am. Use Desmos or use a different kind of calculator and it'll tell you P1 and P2 and PC, and it gives you everything a whole lot better. There is a down, no, there's no down arrow. We got everything we need. So I got the z-score. Remember how to turn the z-score into the p-value if you have to. Normal CDF. That's important to know. But then this one that you'll have to double because it's a two-tailed test. Okay, two-tailed test. 0.24 is way too big. Way too big for anything alpha. It didn't give me anything alpha. My bet is my next question is going to ask me to make a decision. So because my p-value is bigger than any possible alpha, I'm going to have to fail to reject. Greater, bigger. Fail to reject ho. There is not enough evidence to suggest that the two schools have different percentage of students who missed breakfast or eat breakfast, or I think maybe that's what you were asking about earlier. Missed breakfast, I think is what it is, right? The percentage that missed breakfast. Yeah. There's not a true difference of students who missed breakfast. Apply. Slideshow. Pencil. There's p hat sub c, but we already showed that. Here's the z-score. You don't have to show all this. You can, you don't have to. We just need that 1.17. There's the p-value, 2.2420. You don't have to show all that stuff. I just hope you know how to get it all. You don't have to show all that stuff. And now what's your conclusion? And they told me alpha is 0.05, but again, they didn't have to tell me what alpha was. I'm bigger than any possible alpha value. Because the p is greater than alpha, we fail to reject. Greater, fail to reject. Greater, fail to reject. There's not enough evidence. Don't suggest that ho is true. We can't do that. We just didn't have enough evidence to say that ha was. There is not convincing evidence of a difference in the true proportions of students at school 1 and school 2 who skipped breakfast that day. I think, yeah. That's where I got my conclusion. I always get it from the question. They're going to write it the way they want me to write it. So I'm just going to use what they did. Use their question to answer your question. Use their question to answer it. And you won't be wrong. Okay. Pencils. Let them go. Or not. Rice cakes? No, what we get today? Protein balls. That's what I thought. Looked like they weren't open yet. Here's how you do it on the calculator. What's this say? Oh, the formula for the two sample often leads to calculation errors by students. Although the calculator will do all of the math for you, please let it do all of the math for you. Just doing that's not enough to earn you the credits. Of course, we got to do the conditions. We got to make sure we show something besides just answers. But please make sure you report Z and the p-value. Those are two things you've got to report. You don't have to show step by step. This is putting it all together, so this is one big problem. I'm not doing the one big problem because I'm getting into the errors now. Will a drug to lower good cholesterol reduce heart attacks? The heart study recruited middle-aged men with a high cholesterol, no history of their serious, investigated. The volunteer subjects were assigned at random to one of two treatment groups. Holy cow. 2051 took the gene fibrosol to reduce cholesterol, and the control group took 2030 men. During the next 5 days, 56, yada, yada, yada. Do these results give convincing evidence? That tells you got to do a test, guys. That tells you got to do a test. And when it's asking about convincing evidence, that it's effective in preventing heart attacks, okay? So again, I'm not going to do that entire problem. I did want you to see it so that you can kind of see how it's going to look Monday on your test. What's one thing about this one that stood out? Experiment. So we don't check the 10%. Okay, don't check the 10%. If you didn't recognize that, you got volunteer subjects. I don't like to say we got two random independent SRSs because I don't have two independent SRSs. I have two randomly assigned groups. So make sure when you state things, guys, you state it correctly. You don't be lying, right? I told you that you can write a lot of stuff and just don't lie. Two independent random SRSs. No, you don't have that. You lied to me. Don't lie. So here the whole thing is, there's your ho, here's your ha, here's defining the P's. That's the uh-oh a lot of students forget. Notice they did G and the PL for the placebo. The plan, random, large count, so that's my conditions, okay? Here's the calculations. That's way more calculations than I think you should do, but it's beautiful. I would definitely have P hat sub G and P hat sub PL and P hat sub C, and I would have the Z score, and I would have the P value, and I would have alpha, and I would have N, and I would have everything I could, but don't mess up to where you're putting stuff wrong. And then we got a P value of 0.0068, so we have to reject. Good enough with all that stuff? Y'all okay? All right. Now then, oh, let me make sure. Hope you can do the hypotheses. Hope you can determine if the conditions are met. Hope you can calculate the Z-score and turn it into the p-value. And then, of course, perform the entire significance test. Okay? Now, your errors, I think, go back to 9.1. I think that's where your errors are. So this is kind of all new, guys. I've never done it this way. So I hope this way works a little bit better. But I apologize for your notes. No, I don't want that. I want the errors. Where'd I put them? Oh, here it is. Errors. Okay. Big picture here, right? We made one of two decisions. You either reject or you fail to reject. You either reject ho or you fail to reject ho. Well, because we made one of two decisions, it's possible we messed up. It's possible. There is a chance of getting that tested or that sample we got. It's just we don't think it's a good one. So we're going to reject the null. However, there's still a chance we got it. So we still weren't supposed to reject. Y'all okay with what I'm saying? Good? So we go ahead and we don't change anything else. The only time we talk about errors is if they ask. Don't say we could have made an error unless if they ask about it. Is it wrong if you do it? No, but if you say it wrong, it is. So don't talk anything about errors unless they ask. Okay? All right, here we go. That's a big thing I want to get out. Clicky, click, 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 click. So when we perform a hypothesis test, we made one of two decisions. We either reject or we fail to reject. If P is low, the ho's got to go, you reject it. If P is not low, then you got to fail to reject it. okay? Both of those could be a wrong decision, either one. You're only going to make one of these. You're only going to make one decision. So if you make this decision, you could have made that error. If you make this decision, you can make that error. So there are two errors, but you can only make one error because you only made one decision. Okay? Each are possibly wrong decision. Therefore, there are two types of errors. And boy, they went out on a limb to call these errors, and they call it a type 1 and a type 2 error. That's what they call it. Type 1 and a type 2 error. And they use Roman numerals. Type 1 and type 2. And the AP won't care if you use Roman numerals or you use regular numbers, but whatever. Okay? A type 1 error can only could occur if you reject. If you reject ho, you could have made a type 1 error. You could have made a type 1 error. So what does that mean? Well, if you rejected it, basically you're saying it's false. It wasn't false. It was true. We had enough evidence to suggest that it was greater than 60%, and we shouldn't have. It's not. We just made an error all the way around. So a type 1 goes with reject. In other words, we rejected a true ho, a true null hypothesis. We rejected a hypothesis that was true. Now, we didn't say it was true, but we could have. We rejected it, so we said it was false. We had enough evidence to say that yada, yada, yada. And we were wrong on everything. We shouldn't have rejected it, and we should not have had enough evidence. Okay? That all goes with type 1. That all goes with type 1. Type 2, boy, they make this nice for you. When you fail to reject. Fail to reject. I mean, they didn't spell it right, but they said it right. Type 2, fail to reject. It also goes with my length of letters. If it's greater, you fail to reject. There is not, you could have made a type 2. Whereas if it's a reject, and if it's less than you reject, there is, and I could have made a type 1. All the small ones go together, all the big ones go together. You can't make a type 2 if you rejected the null. You can't. You just cannot do it. And if you fail to reject it, you cannot make a type 1. You can only make a type 1 if you reject. And you can only make a type 2 if you fail to reject. Good enough with that? Here was my conclusion. Okay with that? I can either reject ho or I fail to reject ho. One of those two things is your conclusion. You had to do that. Well, if I rejected ho and ho is true, if I rejected it, but it's true, that is a type 1 error. This might be different than yours. Did I put the rejection on the left? Okay. I switched it one year. I put rejection up here and true down here. If you reject it and it's true, that's a type 1 error. That's a type 1 error. Now, if you reject it and ha is true, if you reject ho and ha is true, if I reject the ho, there is enough evidence to suggest that's a correct conclusion. I didn't mess up there. I didn't make a mistake. That's right. That's right. And we most of the time make right decisions because we think, I mean, if we weren't doing all this stuff, then we wouldn't be doing the statistics. But statistics say we can make mistakes. We can make mistakes. If I fail to reject ho and ho is true, that's a correct conclusion. That's a correct conclusion. That's a conclusion that we can make that we are not messed up on. However, if I fail to reject ho and I say there's not enough evidence for ha, that's a mistake. That's a mistake. That's the type 2 error. Sometimes AP or textbook and things like to put it in these little tables every once in a while, and you'll see a couple on your homework. I don't want to get really in depth with this because this is not a big part of AP. However, the mistake, you can kind of, I think you know when type 1, type 2 is good. Okay? Good? Clear? Clear? Good. Talk a couple of things else, a couple more things. So if they ask you to talk about it, basically you said you messed up. We said this. I mean, what did you say? Well, we said ha was true, or we said we had enough evidence for ha, or we said we didn't have enough evidence for ha, or we rejected ho, or we failed to reject ho, whatever you said. I mean, if you reject it, then you said you had enough evidence for ha, and when we were wrong, I mean, we're just going to do the opposite. Or I rejected a ho and I should not have rejected it. I don't know exactly what you want to say on that. Fair enough. I think they're both accepted. If you said, whatever you said, if you reject it, then you said you had enough evidence for ha. One of those two. I wouldn't talk about both of them. I would just talk about, I'd probably go with my ha. I don't want to make it believe that I said ho was true, but I don't say it was true. I said I rejected ho, or I didn't have enough evidence for ho. I don't know just whatever you decided, and you messed up. You lied. It should have been the other. Y'all okay with what I mean by this? Yeah? And you're just going to put it in the context. You're going to put it in the context, whatever it is. I said the two schools did not, let's see, well, we failed to reject that, right? The two schools had the number of students or the percentage of students who skipped breakfast. I said the true percentage of the breakfast was, I rejected it. I failed to reject it. There was not enough evidence. So I said there was not a difference in the true proportion of students at the schools who skipped breakfast was the same, and I was wrong. It was the same. I failed to reject it. I should have rejected it. I think I'm still flipping that around. Okay with that? 28 of you cats in here, and I guarantee it, there's 28 ways to write this. I know there's 2. Because it depends on if you said I said the ho, and it should have been this. Or I said the ha, and it should have been this. Multiple choice, you're only going to have one choice. Multiple choice, you're going to have one choice. And it's tough to discern which one is those is right. Because they're going to try to do everything they can to mess you up on that. It goes without saying that has to be in the context of the situation. Okay, has to be in the context. So what are we talking about? I'm talking about those kids that just skip breakfast. We're talking about the BHS Tiger who makes 80%. That would have been a good one, right? So we rejected the null. We had enough evidence to suggest that it was less than 80%. We were wrong. We shouldn't have rejected it. That Bentonville Tiger actually can shoot 80%. Right? Y'all okay with that? That's different than the consequence. The consequence is the result. It's not the definition, it's the result of that. What's the result of that Bentonville Tiger? Well, I said that Bentonville Tiger can't shoot 80%. So what's that mean? Well, at the end of the game, I don't have him in because I don't want him shooting free throws. When in reality, that was a mistake. He should have been in the game. He should be the one getting fouled. He should be the one making the free throws. But I made the mistake and say that he can't do that. He, she. In a breakfast, what's the consequence? Well, the consequence is we're giving more free reduced lunches, or we're giving away more breakfast, more free breakfasts out. When in reality, we don't need to be doing that because it's the same amount both. I don't remember exactly what the decisions were, but the consequence is the result. What happened because of that? What happened because of that? That's the consequence. That is the result. Don't talk about the consequence unless they ask for the consequence. Don't talk about the definition unless they ask for the definition. And don't talk about the errors unless they ask for the errors. They will specifically say what is the result or what is the consequence of this. What could be the consequence? Don't talk about any of this stuff unless they ask. That's probably one of the biggest mistakes I've seen from students the past 4 or 5 years is this could have been a type 1 error, or they could have made a type 1 error because we and they go on and write a whole paragraph about it and they didn't even ask about the errors. Don't talk about the errors unless they ask. If they ask what type of error, type 1. Type 2, I mean, it's just a quick answer. Explain. We got bad information and we rejected when we should not have. Something like that. Hence, all these things do go together, right? Greater, fail to reject is not type 2. But I can't help you much more than fail to reject. Less, reject is type 1. They all go together. So if you reject it, you have to have enough evidence. Don't try to put these things together and don't just keep it consistent. Keep it consistent. All right, here's an example. Let's look at this one. We got a potato chip producer and its main supplier. They agreed that each shipment of potatoes must meet certain quality standards. Well, that makes sense. If I'm going to make potato chips and I'm going to buy some potatoes, that better meet some certain quality criteria before I try to make chips. I don't want a bunch of bad potatoes making bad chips. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck is going to be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload is accepted. To make a decision, a supervisor will inspect a random sample of 500 potatoes. The producer will then perform a test at the 0.05 level. Ho, P equals 0.08. Ha, P is greater than 0.08. If it's greater than 0.08, it's significant because I'm sending that truck back. If it's less than 0.08, that's not significant. I'm keeping it. Where P is a true proportion of potatoes with blemishes in a given truckload. Describe a type 1 and type 2 error in this setting and give a possible consequence of each. Thought I had a blank page. Blank page, here we go. It's the way I do this. When I start talking about these things, I try to break it down as best I can. First of all, I have a ho, P equals 0.8, 0.08. Okay, they told me this information right now, so that's what I got to go with. All right, so I'm going to do type 1 first. Type 1 first. All right, type 1. Type 1 goes with reject. I reject this. If I reject this, then there is enough evidence for this. I'm wrong. I'm wrong. I shouldn't have rejected this. There was not enough evidence for this. And how you want to talk about all this stuff, I don't know, but those are things you got to keep in your head. So let's see, type 1. I reject this. I said that the blemishes were greater. I said blemishes greater than 0.08 and they, weren't. There goes that dyslexia again. They. I think that's okay. I don't know how much else you want to. I said the blemishes is greater than 0.08 and they weren't. And they should not have been. That's just kind of how I go about through this. Type 1, type 1, type 1. Okay, type 1. I rejected this. If I reject this, I said this. I was wrong. I was wrong. Should not have said this. I said they were greater than 0.88 and they weren't. What happens if they were greater than 0.08? I sent the truck back. I shouldn't have. I should have accepted that. I sent a truckload of good potatoes back. I sent a truckload of good potatoes back. Okay with that? That was the consequence of it. Does that consequence hurt me that much? Not really. That doesn't hurt me that much. It hurts the truck guy. It hurts the potato guy, but it doesn't hurt me that much. I just sent one back that I should have taken. Here we go. Now we'll talk about the type 2. Now understand on AP, right, they're only going to ask for 1. Because if you do 1, you're going to do the opposite for 2. And if you miss this one, you're going to miss this one. So they're not going to do that, right? But here we go. I got ho, P equals 0.08. I got ha, P is greater than 0.08. And now I'm going to talk about the type 2. Type 2, failed to reject this. I failed to reject this. There's not enough evidence to say that they were greater than 0.8, and there should have been. I said the blemishes were not greater than 0.08, and they were. That's where I messed up. And again, I'm going through the whole thing myself of what happened. I said this, so type 2, failed to reject this. If I failed to reject this, there's not enough evidence for this. There should have been. So if there was not enough evidence for this, I said there was not enough evidence to say it was greater than 0.08. They should have been. It was greater than 0.08. And what does this mean? The consequence. I accepted a truckload of bad potatoes. Good gracious, my handwriting's gotten horrendous. Type everything nowadays. Shh. I have feelings too. Go ahead and say something, Z. I dare you. You know better. That's all I got to do is keep you on the edge. There's not one. But if you think one's coming, that's what keeps you interested. See? That's the little carrot you dangle. Unlike other classes, this one's interesting enough. They don't need those stupid things. Nope. Nope. I took a survey and found that 100% of the surveys are answered.
How big was your sample size?
Everybody that answered. Y'all get it, right? Took a survey of how many people answer survey, and 100% answered. Might be biased. Oh, I'm done. I got to go back to this thing. Shut up. Oh, what's up? How you doing? Yes, no, maybe. We're not done. We're almost done. We're not completely done. Durtek, we missed you Friday. You good? Everything okay?
Yeah.
All right, good. Do you have it? Never mind. We'll talk later. Sorry. Type 1, the producer finds convincing evidence that more than 8% of the potato shipments have blemishes when the true proportion really is 0.08. Like I said, there's 28 different ways for you guys to say that, and I think they all are good. The consequence, the potato chip producer sends away a truckload of acceptable potatoes, wasting time and depriving the supplier of money. Type 2, the producer does not find convincing evidence that more than 8% of the potatoes in the shipment have blemishes when the true proportion is greater than. Consequence, more potato chips are made with blemishes, which may upset customers and lead to decreased sales. Like I said, 28 cats in here, and there's 28 different ways to answer that, and you're all right. Most of the time, this is multiple choice stuff, and there's only one way to answer it, right? If it's a free response, you answer it correctly, and you stop. Answer it correctly, and just go, stop. We do know that the most significant levels are always 0.05, maybe 0.01 and 0.10. Right? We've talked about that alpha level. Well, what you need to know, that is the same chance as making a type 1 error. The probability of making a type 1 error is equal to alpha. It's equal to alpha. You need to know that if alpha is 0.05, then there's a 5% chance of making a type 1 error. If alpha is 0.01, there's a 1% chance of making a type 1 error. So if you don't want to make a type 1 error, make alpha small. But I don't think you can make alpha 0, because if you make alpha 0, yeah, you won't make a type 1 error, but you can't reject anything either. If I make alpha 0, there's no way to make a type 1 error. Well, the reason why is there's no way to reject. There's no way to reject, because I guarantee it, the p-value is greater than 0. Right? So because p is greater than 0, then we can't, that's the same thing. And so what I really think they're getting to, guys, is at some point of what should alpha be, or should alpha be lower or higher? And that's where you're going to have to really dig down deep and think of, okay, what's worse here, a type 1 or a type 2 error? Because I'll say this, if type 1 error goes down, that has to make a type 2 error go up. If you lower one of them, you're going to raise the other one. If you raise this one, you got to lower this one. Now, it's not the complement. It's not a 95% chance. It's not a 99% chance. Okay? But they do have a hand-in-hand effect. If you lower one of them, you got to raise the other one. Y'all okay with all that stuff? That's important to know right there. And then I got to talk about one more thing. I know, good gosh almighty, would you shut up? No, I want you guys to have A's. Okay, so which one of these best choice depends on which consequence is more serious. Right? So if the consequence is more serious of making a type 1, we want to lower that chances. If a type 2 is more serious, then we want to go ahead and raise alpha a little bit. And we do all this before we take the test, before we do the test. You got to establish all this stuff prior to the test. You can't do it after the test, because then you're not using statistics, you're using your heart. So we can decrease the probability of making a type 1 by decreasing the significance level. There is a trade-off. If you decrease the chances of a type 1, then you have increased the chances of a type 2. I do think you guys need to understand that. There is a seesaw effect. It's not a linear seesaw effect, but there is a seesaw effect. If we make it more difficult to reject, then it's going to be easier to fail to reject. And if it's easier to fail to reject, it's easier to make a type 2. Just, again, soak all that stuff up. You kind of need to know that stuff. Okay? It should somewhat make sense. You need to know that the alpha and the probability of type 1 are the same. You need to know that. That's a multiple choice question on the test, and I hope that's like one of those that nobody misses. Because you can go with that. Once you guys get that studied, you got that down. This is my least favorite thing to talk about in the whole entire world. I don't like talking about power. And next year I don't have to because they're getting rid of it. But let's talk a little bit about it because there'll probably be one question on it this year. Power is the probability of not making a type 2 error. I don't know where power is. You see it on your notes? It should be on there somewhere. My guess is it's on 9.3. I'm sorry. Is it not there? You don't see power?
I don't.
Can't find power anywhere? Go to the end of 9.3 and you got room, I think, to write about power. I'm sorry about this. I didn't talk about power for a couple of years. I just ran out of time. So I'm just going to give you the quick, this is like the Cliff Notes version of a type or power. Probability of not making a type 2. Now that's not the same as making a type 1. Okay? Type 1 is type 1. Power is a probability of not making a type 1, which is kind of the same as making a type 2, but it's not the same. You'll see this sign effect here. The seesaw thing is what I keep talking about. Power is a probability of not making a type 2. Not making a type 2. You need to know 3 ways to increase power or decrease power. 3 ways. 3 ways. One of them you kind of already know. So let's. Power is the probability of not making a type 2. If I'm not going to make a type 2, then I'm going to make a type 1 more likely. Therefore, alpha has to increase. Okay with that? Again, if you can tie all that together, you're pretty good. I know right now I'm just hammering you with all this stuff. Whoops. Dang it. And of course, and then I start off with the sample size. There it is. Significance level is larger. If you increase the significance level, you increase the chances of a type 1 error. If you increase the chances of a type 1 error, you have decreased the chances of a type 2 error. If you've decreased the chances of a type 2 error, you have increased power. Holy cow. If you increase the chances of a type 1, you have decreased the chances of a type 2. If you've decreased the chances of a type 2, then you have increased power. Power and type 1 go together. They're just not perfect. So if you increase alpha, you have to increase the significance level. I have the second one up here. If you increase the sample size. If you increase the sample size, what have you guys learned? That decreases the spread. And if you decrease the spread, that means there's less area in the tails. And if there's less area in the tails, you're more than likely to reject. And if you're more than likely to reject, you're more than likely to make a type 1 error. If you're more than likely to make a type 1, you're less likely to make a type 2. If you're less likely to make a type 2, you're more than likely to increase power. Holy cow. But that's what's nice, right? If you want to increase power, increase sample size, increase alpha. Increase, increase, increase. And I have control over those 2 things. I have control over sample size and I have control over alpha. The third one is next to impossible to remember, and it has nothing to do with me having any control over it. Let me do it this way first. We say ho P is equal to something, right? If we reject it, we know this is a lie. If we reject it, we know this is a lie, and it really wasn't this. The further it really is from what we claim it is, increases power. The null and the alternative parameter values are further apart. They're further apart. We have no control over this stuff. You will see a multiple choice question every once in a while on this. You'll see a couple on your notes. I'm pretty sure you will not see one on a test. The other two are somewhat, they kind of make sense. The alpha and the sample size. This one is the further the claim is from the truth. Wait a minute, we thought we said we have to believe the claim is true. Well, we do until we reject it. When we reject it, it's no longer true. So the further is the truth is from the claim, or the ha from the claim, the further it is, the increased power. Power is not that big of a deal. As you're starting to study, don't study power. Go from power at the bottom of the list, errors, and then how to do hypothesis testing. Good enough with all that? Clicky, click, click, clicky, click, click. If I used 0.01 instead of 0.05, what did I possibly do? I must have decreased the chances of a type 1. If I decrease the chance of a type 1, then I have increased power. Decrease the chance of type 1, I decreased power. I went from 0.01, I used that instead of that, so I went down. Okay? I decreased the chance of a type 1, therefore I decreased power. Blankety blank, 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 blank. Okay, I'm done. D-U-N. So this is your homework for tonight. You got 9.3, and then you're going to see 9 errors, 2 different assignments. Okay, 2 different assignments. 9.3 I got due on Wednesday. Errors I got due on Monday. The review will show up Wednesday, but I may have it show up now too. And the review is due on Monday. All that's out of Achieve. Okay, all 3 of those are out of Achieve. So you have 9.1, 9.2, 9.3, 9 errors, and 9 review. 5 things out of Achieve, 25 points. Okay, I'm going to give you a worksheet on Wednesday that has the Frappy and it has some other stuff on there. It's all free response. And then I'm also going to post the multiple choice questions like I've done for the first 8 units on Google Classroom. Yes, no, somewhat, maybe. And then on Wednesday, I'll tell you what to expect on the test, but you should pretty much know. You're going to see a significance test. You're going to have to do the full-blown deal. I bet it's got something to do with Jesus being better than goldfish. Or you might reject it. I don't know.
Is that going to be a hint at the answer?
Don't you defy mathematics, even though you know that it's better. Let me hit this button here, hit this button here, hit this button here.